Okay, so we're gonna have a part A take 2 because teams didn't do things correctly. That's disgusting. Oh yeah, my secondary angle's over here. Got it. And as you can see, yeah, you can see all my stuff. Wait, let me put it over here. As you can see everything. And all right, let's go to the homework. Hopefully my device that I write on doesn't die because I lost the charger somewhere. Okay, so starting from the basic principle of why the approximation error should be perpendicular to the basis vectors, derive the matrix vector equation for the multilinear regression. So let's open this up, and I'm going to be writing on this. Yeah, you can see it. Okay. Oh, the battery's running low. How low? Please, God. 6%. Jesus. Okay, so we're going to go to OneNote, and yeah, you can see it on here. We're going to go to, oh wait, no, part A, take 2. Okay, so part A, take 2, we're on there. And so what we're going to start with is a little drawing or something to display. So this is going to be our independent variable, C1, U1, and this is going to be our estimated values times our independent variable, or a coefficient, which is why it's C. This is going to be our dependent variables. Oh dear God. And this is going to be our error, approximation error. My screen is getting darker. Okay, so with this, I'm actually going to write the equations out. So our dependent is equal to our coefficient times our independent variable times our approximation error. And then we're going to rearrange that into our approximation error is equal to our dependent variable minus our coefficient times our independent variable. So now what we want to do is why the approximation error should be perpendicular to the basis vectors, right? And so when we're going to do a dot product, so we want to minimize our approximation error, right? We're going to dot product that with our independent variable. And so like with vectors, to get that 0, that minimization, you have to have things be perpendicular like this, right? So you want it to be minimized. So like, let's say we minimize our C1 value, which we're going to solve for, or get that independent, not independently, but isolate that later. You want your C1 to be smaller, and we change this around. Okay, so we're actually going to plug this into here using the dot product, right? So V1 and C1, U1. Well, I probably should have gone over what everything was. So I'm going to actually do that after I set this up really quickly. Hopefully this doesn't die. Okay, so let's go here. Our V1, yes, it did it. So V1 is equal to our dependent variable vector. You can see there. Okay, so E1 is our approximation error vector. I'm not even going to check the battery. It's just going to die. And we'll use Calvin's iPad. This is our independent variable vector. And then our C1, which isn't really in any direction at all, but it is our estimated values or a coefficient vector. So now I'm going to go back to what I was doing over here. Right, so we're going to do the dot product. So we're going to have, please start writing. Okay, V1 dot product U1 da da da, and then minus our coefficient times U1 dot product U1, right, is equal to 0. And so what we want to do is we want to isolate that, our coefficient, right? So you subtract, or you add this to the other side, and you divide by this right here, and then you're going to get your coefficient is equal to, let's erase this, V1, please write, V1 dot product U1 over U1 dot product U1, right? Oop, do. And that will be our matrix vector equation for multilinear regression. I'm going to